Hello and welcome to the video lecture on LED toggling program for 8051 microcontroller in embedded C. In this video, we will first go through the Proteus software where we are going to draw the simulation diagram for this project, and then we will write the program in Kill for the same project, and then we will run that program and check the output in Proteus. So let us start with the video by drawing the diagram. Now here actually we are using the port P1 of the device AT89C51 microcontroller. So first you have to go for a new project. So how to create a new project in Proteus? So for that you have to go to File, click on New Project. Here you have to give the name of the project. Here we are going for toggling of LED. So I will give the name Toggle LED, and then you have to click on Next. Now you have to go for a default design template and select create a schematic from selected template and go to next. Then here select do not create a PCB layout, because here we are not interested in creating the PCB layout. So just click on next. Here select no firmware project, and if you want, you can select create a firmware project, and you have to fill all this information. But here I am selecting no firmware project. Here I am only going for a schematic, so just click on next. So here if you can see, it will select this option of drawing the schematic and click on finish. So now this window is open for you, and here we are going to draw the schematic for our project. Now here you have a component mode where you can pick up the different components. So here P and L, there are two options. So P is for pick up the devices from library. So first we want to take the device AT89C51. So you have to just give the number and you will get this device. Click on OK. Then after that you will need a LED. So I am just giving the LED Aqua. So when I type this, here is a LED Aqua model. Just click on OK. You can take any other LED also. If you just type LED, you will get a list of different LEDs and you can select any one of it. Then we need one series resistor, so you have to go for a resistor, and you can take any resistor from the list and click on OK. So these three are the components that we need for our diagram. Now select this controller and put it here. Now we are using the port P1 of this. Now we want to connect the LEDs. So here I am going to connect the 8 LEDs, and we are using or connecting the LEDs in the syncing mode. The syncing mode means the anode terminal of all the LEDs I am going to make it common, and the cathode terminal of individual LED I am going to connect it with the controller. So just connect the 8 LEDs here. Just copy it to clipboard and just go on pasting it. So now connect the anode terminals of all the LEDs together and connect the supply. For connecting supply, right click, then go to place, go to terminal and connect power. So, and now the cathode terminals of these LEDs I am going to connect with the individual port pin. What is the interfacing diagram? Now just save this project. Now we are going to write the program for this simulation diagram. So let us go to the Kill software. Now here we will go for a new project. So give the name Toggle LED and just save the project. Now here you have to select the device. Now we have used AT89C51 in Proteus, so we will take the same device, otherwise your program will not run. You don't need any startup file, so click on No. Now go to File, New. So this is what is your editor is. So here I am writing this, the program Toggle LEDs connected to port 1 of Nancy 51. Now first you have to include the header file, that is reg51.h. Now this file you have to include because it contains all the basic definitions for the microcontroller 89C51. Then we are going for using the hash define. So hash define LED P1. So I am actually using the name LED wherever I want to use the port P1. Then here you need some type of a delay because we are toggling the LEDs. So I am going to declare the function which is delay function. So this is what is a function declaration. Now after this, let's go for the main program. So void main void. Now here actually we are going to toggle the LEDs. So the first value that I am going to load into the LED, that means at the port P1, is 0x55. Now why 0x55? So let us understand that. Now if you represent the value 0x55 in binary, then it will be represented as 55 means 01010101. This is what is the basic pattern. So in this pattern basically we are going to make these alternate LEDs on for some time, and then after that I am going to invert this complete pattern. So when I invert the complete pattern, that means this 0 I am going to make it 1, 1 I am going to make it 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, and so on. And now if you check this value, it comes out to be AA. So if you load the values 0x55 and 0xAA to the port P1, then you will get the toggling action on the port P1. So you can observe that first these 4 LEDs are on, then there will be some delay, and after that delay then the remaining 4 LEDs will be on, and again there will be an delay. So this is what is the program. So for that reason actually we are going to load the pattern 0x55 and then I am going to invert it. Okay, now after this I am writing one infinite loop, that is a while one, and in that while loop I am going to invert this 55 value. So if you can see I have written LED is equal to invert. Invert LED is a tilt operator, that means it is an inverter operator. So when you invert the value 55, your value will become AA, and then here you call the delay routine. Now here I am going for a delay of 250 milliseconds. So I have passed the value 250 here. Okay, and I have completed the main program. So this is what is my main program is. And now the last part of the program is to define the delay function. So here you have to write the delay. So void delay unsigned integer. You have to declare one variable, that is I time. Here I am generating the delay using two for loops. So for that for loops I am declaring two variables, that is I and j. Now I will write a first for, that is for I is equal to 0 to I less than I time I plus plus. And in that for loop again I am declaring one more, that is j is equal to 0 to j less than 113, that is j plus plus, and simply close the bracket. So this is what is the delay function. So how the entire program will run. So initially the port P1 is loaded with the value 0x55, and then in the loop when you are going to toggle it, then first 55 will become AA, then there will be a delay, again 55 delay. Now when you call the delay function, then this 250 value will get assigned to this I time variable. My outer loop of I will run from 0 to 250, that means 0 to 249, and the inner loop will run from 0 to 113, and collectively it is going to generate the delay of 250 milliseconds. So now this program is complete. Now we will first save this program. So while saving the program, you have to give the extension. So it is here I am writing it in C. So toggle led.c is a name. Now you have to add this file in this source group one. So right click on this, add existing file, and you have to add the file. So just go through this list, you will get your program here. So toggle led, that means start from T. So otherwise you can type it here, the name. So toggle led.c. Now simply add and close. So you can see that file is added in the under the source group 1. Now we have to check for the errors. Okay, so let us see, or let us check for the error by building the program. So just once again save and build the program. So here you can see there is 0 error and 0 warning. That means this program is syntactically correct. Now actually we want to load this program into the controller in Proteus, but for that reason we need to generate the hex file. So for generating the hex file, you have to right click on target 1, go to options for target 1. Here you change the frequency to 11.0592 megahertz. Then click on output and select this box create hex file. Click on OK and again build the program. Okay, then you will get the message creating hex file from /object /toggle led. So now your hex file is generated here in this folder. So that name of the folder or path is given here, C:user Samsung. So whatever is your folder and path, you have to go with that, and you have to browse your hex file. Okay, now we'll load this file in this Proteus. So again come back here, right click, sorry, double click on the controller. Here you can change the value of or frequency. Here it is 12, make it 11.0592, and from here you have to browse the hex file. So my hex file is desktop, in desktop, kill projects, in kill projects objects, and in objects I can type here the name. So I will give the name toggle led. So here you can see toggle led.hex. So this is the file, open and OK, and now you simply run the simulation. So you can see here the output of the program. So first 4 LEDs are on, remaining 4 are off, and after a delay of 250 milliseconds, the LEDs which were on previously, they will be now on, and vice versa. So this is basically called as an toggling of the LEDs which is connected to port P1. Now you can connect it to any other port also, but when you connect it with the port 0, then in that case you have to connect the external pull-up resistors, because your port 0 is not internally pulled up in 8051 microcontroller. So only that care you have to take. And if you want to change the delay, you can change it in the main program. So just go to kill, and if you just change the value from 250 to 500, then you can easily see the change. But you have to first save and again build the program and again run the simulation. So see here, the delay is increased, which you can see clearly in the Proteus simulation. So guys, if you like my video, then please subscribe to my channel and share the video with your friends. Thank you guys. Thank you so much.